Here we go. Page 140 of our student journal. Today we're 5.4, solving radical equations and inequalities. We'll actually do this today and tomorrow. We'll spend a day on 5.5 and then go to 5.6 for a couple days, and then we'll have a test next week. On page 140 of your student journal, yours looks more like this, but talks about solving radical equations. We're going to walk through a bunch of these today, but there are the steps. We're going to go through some terms that you may not have heard of before, but extraneous solution, radical equation. Radical equation is just an equation that's really cool, okay? Or that has a little radical symbol in it, probably more so, okay? It could be to any power, okay? They're pretty powerful things. And some of those will give out extraneous solutions, which are extra answers, which don't work. They're imposters, all right? So they start kicking out these imposter solutions. So when we start seeing those today and we figure out when those occur, you may want to put a note there to yourself. All right? So with that being said, we're just going to dive in and try some of these problems because really it is applying what you've done in the past. So what I want you to try, let's start with number 1 there. Okay, this is page 141 of your student journal. On number 1, I want you to just solve it like you think you should. Okay, do everything you would do to try to solve for x there. Give it your best go. Helps you, you may want to use those steps on the previous page. Okay, hey, try number 2 once you're done there. Hey, to volunteer to do number 1 up here. Yes, Dallas, all right, come on up. Right up here. Yeah, on the paper. Just bring your pencil up there. Grab your pencil.
Yeah.
Once you finish number 2, go on to number 3.
Whoa. Does this show up? Okay, it does show up. Got square both sides. Yeah. Minus x equals 49. Plus x 1 equals 49 plus x minus 49 minus 49 equals x equals negative 48.
Okay, anyone second that answer? Negative 48? Yes, very good. Hey, just using inverse operations, get rid of the radical before you deal with the 1 minus x there. Number 2? Go ahead, Abby. If you need help, make sure you ask me as I turn it around.
Oh. Oh.
You're trying to get rid of 1. You have 4 by 4.
No.
That's a 3.
Right now you're multiplying that 1. So you divide it. So then 4 divided by. Oh, okay. That's why you get rid of it.
Here's my Trig class. Like at the beginning of our final. Pretty funny. It was a good chuckle. All right, hey, negative 13, who got it? Okay. Hey, really good job here. If you're using your calculator to cube negative 4, I would hope you didn't, but if you are, you would have to put parentheses around it in order to get that negative 64. Okay, so if you ended up getting positive 64 here, well, I guess it wouldn't matter because you're doing an odd power. It'd give you a negative anyway. But if this was an even power, it would make a big deal. Okay. But very good job. X equals negative 13. Okay, how do you know if you get imposter answers or extraneous solutions? Yeah, you'd have to plug it back in. So if I did 5 times negative 13 to get negative 65 plus 1 is negative 64, and the cubed root of a negative is negative 4. That works. I put negative 48 in. X minus negative 48 is 49. Or 1 minus negative 48 is 49. The root of that is 7. No imposters yet. Okay. Any questions on those two? All right. How many are done with number 3? Okay. Volunteer to do number 3? A couple ways to go about it. You got number 3? All right. Very good. Who else need to get their Chrome?
Well, I'm not done, so it doesn't matter.
All right, volunteer to do number 4. No, I can't do another one.
We want you to be wrong, Zach.
All right, so Aaron subtracted 6, multiplied by 4. Good. Then took and raised it to the 4th power. Then divided it by 2, 32,768. Anyone second that? Number 3. Does it work when you plug it in? Yeah. Very good. So number 3, 32,768. Well done. Okay, really it's just following those inverse operations right now, right? No big changes yet.
Wait, oh, oopsies, that's a 125. There we go. So this is like 130 or whatever. That's just 13x. It's like 11. Right? 13. Or no, that's a 10.
Did the math.
Did I do that right?
Of course I did the math.
What? Oh. This is difficult.
I know. I have to spend hours practicing moving the paper.
Right there.
All right, well, let's check number 4. Number 4, first step, Zach, divide by 2. Well done. So it gets a 5 and cube root of 13x minus 5. And then from there, we'd have to cube that. So we get 13x minus 5 is equal to 125. Add 5, you get 13x 130. Divide by 13, and x is 10. Good? Yeah? Okay, 13. And we plug it in. We plug that 10 in. 130 minus 5, 125. Cubed roots, 5 times 2 is 10. Good. Okay, any questions so far? How many got all 4 of them? Okay. Number 5. Everyone try number 5. Okay, volunteer to tell me what you did first. Matt? Oh, I'm sorry. Yeah, go ahead, Matt. I meant Dallas. I said Matt. Go ahead, Matt. Yes, Dallas, is that what you did? All right. Squared both sides. Why'd you do that? Okay, to make it unradical, you square both sides. So x minus 7, quantity squared, or if we just multiply that out, that's x squared minus 14x plus 49. Everyone good with that? Okay. Let me zoom in so we can really enjoy it. Okay? And it's blurry. A little less blurry. Okay? And that's x minus 5. Okay, now what? Oh, Dallas. Okay, pause. Why would we do that? Someone else. Why would we want this to equal 0? What tells us? Autumn? Very good. Yeah, we have a quadratic. We set it equal to 0. We can use quadratic formula or try to factor. So move all that over. We get x squared minus, so subtract x over 15x. Add 5. Okay. Can we factor x minus 6 and x minus 9? Poor 6. All right. Equals 0. Okay, and we could use quadratic formula, but if you factor, we'll go for it. And that tells us x equals 6, x equals 9. Very good. We have our solutions, and are we... That's supposed to be a bracket. Okay, are we good? No, we check them. Okay, before we check them, any questions up to there? Okay, waited the mandatory 7 seconds. All right, plug in the 6. 6 minus 7 is? Negative. Now, everyone that's paying attention here, when I put 6 in, I get 6 minus 7, and that is a negative. It's a negative 1. And I have a negative 1 equaling a square root. Everyone see the problem? Can't take a square root and get a negative. Okay, therefore, this is not going to work. Okay, that is extraneous, also known as imposter by us. Okay?
Not a negative under the root, it's a negative as an answer.
No. No, because you didn't impose the radical. And 9 minus 7 is 2. Okay, that seems okay. And 9 minus 5 is 4. Square root is 2. Good, 9 works. 9's our real answer. There we go. Officially cool. Any questions? That's the first one we've got with an extraneous solution. Notice it looked a little different. It had x's on both sides. Okay? So, will number 6 have extraneous, you think? Has x's on both sides? Alright, let's try it. Try number 6. Okay, quick mistake. Hey, I need everyone's attention back up here, please. Quick mistake. When you cube this, this should be 3 cubed and x cubed, or 27x cubed. If you just put 3x cubed, that would be a common mistake. Okay. Hey, we collect the x's on the same side. We get 486 is equal to 54 x cubes. We divide by 54, we get x cubed is equal to 9. You take the cubed root and you get x is cubed root of 9. Common error, yes. Keep in mind, when you do an odd root, you only get, you don't put plus minus. Alright? Autumn. No, because the cubed root of 9 is the number that multiplies by itself 3 times to make them. Common error, though. Okay? All right. So did we check it? Hey, that may seem a little daunting to put in, but when you plug it in right here, the cubed root of 9 cubed is 9. 9 times 27, 243. 486 minus 243. 243. Okay? And we plug in cubed root of 9 here and multiply it by 3. It should check out. We should be good to go there. Okay? So, this one had x's on both sides. No extraneous here. This one had x's on both sides, extraneous here. Will number 7 have extraneous, you think?
Yes, it will. No doubt.
Bless you.
Thank you.
Good kiss.
All right. Number 7, give it a go. Said, holy shnikes. Hey, some of you are like, hey, let's work easier in math. You could divide by 4. You could. Or, you know, what's the next step after dividing by 4? Square it. So let's square first. Okay, it just means you have to square the 4. 16 times x plus 1 is equal to x plus 1 squared. That seems to be a little easier, I would say. Okay? Rather than dealing with a x over 4 and 1/4. Or excuse me, yeah, an x over 4 and a...
Where do you get 16?
Okay, if you take away... No, you can't do that.
15 equals x.
All right. Now, some of you may say, hey, let's divide out that x plus 1. I will tell you if you do that, you will lose one of your answers. One of your answers disappears. So probably not a good idea right there. Okay? So if you divide out the x plus 1, I like the math that you're looking at, but you end up losing one of your answers because you have a quadratic over here with 2 answers. You're dividing one of those solutions out by doing that. Okay? So what I would do is I'd probably expand both sides. Get all the x's collected on one side. Set it equal to 0, in other words. So subtract our 16x and subtract our 16. Factor if you can, which you can. And get your two solutions of 15 and negative 1. Now the question is, are both those solutions going to work? 15 plus 1, 16. Root is 4 times 4 is 16. 15 plus 1 is 16. That one works.
Okay, wait.
Negative 1 plus 1 is 0. Root of 0 is 0 times 4 is 0. Negative 1 plus 1 is 0.
Okay, so I did something a little different, although, okay, no, I lost it. Okay, so never mind. I didn't get negative 1. I only got 15. Okay, never mind.
Did you divide out the x plus 1? Right up here?
I don't know, that's not how I was thinking. I just basically saw that x plus 1, and I saw that there were 2 x plus 1s on the other side. So I made it so there was just 1 x plus 1 on the other side.
You divided out x plus 1. Which got rid of one of yours.
Okay, so I'm sorry. I didn't use that terminology. That's my bad.
Hey. Very good. Hey, they both work. How many thought there would be an extraneous there? Okay, no extraneous there. Unbelievable. Okay, why don't you try number 8? Will there be extraneous? Take a guess.
Yes.
Maybe.
Just gotta say yes all the time.
No, they're just like always standoffish. A little bit. One guy was he said that, you know, how are you doing? I don't know if you heard me. No, I think he was probably.
Mr. McCoy,
Yeah.
are you sure that's a 1?
No. Thank you for checking my work.
See, I do that all the time. I'll just put a random number in between something
A lot of times I think it's because you're thinking ahead. That's what happens with me. I'm thinking over here. Okay, ladies and gentlemen, I get x equals -1. Who got x equals -1? Okay. Hey, notice you could do it. I did the factoring way. You could actually just isolate it x. Either way is fine. Okay, but you get x equals -1, and it works. No extraneous. Sorry. Unbelievable.
Is there actually a way to tell whether it's going to be extraneous or not? Or
It's a good question. That's what I'd be asking. But I already know the answer, so I'm not asking. Okay? Hey, number 9, give it a go. We should be. I gave it to you 1 minute ago, and how could we not be done with 9 yet? Okay? I mean, you move that over and you get 12, and then what do? Divide by -1 and you get -12, and you are done. Why should you be done now? You cannot take an even root and get a negative. This is a no solution. Not extraneous, it's just no solution.
Which means the next one is extraneous. Because you said that there was one more.
It's good reasoning. Wow. Okay, number 9, no solution. Make a note to yourself, an even root, even roots cannot equal a negative. Wherever you put those notes that you study right before your test, have a page where you're like, man, I better study this right before my test or review this. Better put that one on there. Even roots cannot be negative. Good job. Okay, as Walsh has pointed out, you're probably getting an extraneous solution on number 10. Give it a go. Okay.
It's not her fault. I forgot it. No, you're both mad at me. I forgot her name for like half a second. It wasn't like your name. It was like it was slightly lower. Okay, guys, we're going to say I stare at her. You stare at her.
Hey, can I have your attention up here?
It's not.
All right. How many did that first? Okay. What do we end up? Actually, I'm going to pause there. I want you to go through with your neighbor. Show them what you've done from there. Hey, ladies and gentlemen, I kind of miss. How many of you did this one? So I kind of misled you into doing that because of the way we approached this problem. All right? Really, because here you're dealing with multiplication inside. If you move the 3x over here, which I know some of you did, I talked to a few of you as we were walking around. Some of you actually brought this piece over first. And you said, well, that's just 3 root x plus 1. And then we could square both sides, and you'd have to move everything back over. And you eventually end up with the same thing. Those of you who did this first and brought it over, is that correct? Okay. Now, there's a difference here. On this one, note when I square both sides, I'm squaring that and I'm squaring that. This right here, think about the problem you're tying this to is this problem. Let's rather than using, well, let's use a big X to represent our radical. This radical is X, that's plus 2 squared. What do you have to do with that? Yeah, you have to use FOIL, right? Or distributive property. So, I know, groans of joy. So, this X plus 7 plus 2 squared is actually the root of X plus 7 plus 2 times the root of X plus 7 plus 2. And all of that equals 3 minus X, if that makes you feel any better. I mean, that's easy on that side. So what's important for you to recognize is if you're adding pieces, like a constant out here, things that can't be combined, or something that if I move it over, it's not going to be able to be combined with the other side. Like up here, if we move it over, we can combine this with that. It's 0. Okay? It's not going to change what it looks like. But you have a binomial here. Okay? And that binomial squared gives us, well, this times that is just X plus 7. That part's easy. This times that is not as easy, and that times that is not as easy, but it gives you, if you follow the pattern, it's twice of whatever our A term is. So this is that times that, 2 root X plus 7, and 2 root X plus 7. So 2 of those gives us, tell me if I'm off the screen. Okay. I get X plus 7, that's this. I get 4 root X plus 7. And I get 2 times 2, which is 4. It seemed so easy just a minute ago. Everyone's like, this is an easy problem. No extraneous room. Okay? Now, let me pause, let you get your breath. Okay? Collect all of our x's. Collect all of our constants. So I have an x here. I can move over. Subtract. It gives me 3 minus 2x. That's now gone. I can move my 7 and my 4, which is 11. I can move that over by subtracting 11, which gives me negative 8. Okay, so now that's gone and that's gone. I have negative 8 equals 4 root x plus 7. Now what? Divide by 4, right? Do that first. Since both of these, or better yet, let's square it first. Hey, do we have to do the same tough stuff? Good, it's multiplication. Yeah. Emphatic knows. Okay? So when we square that, we get 16. We square the x plus 7, the root x plus 7, you get x plus 7. You square this side, you get a joyous polynomial or a trinomial. Okay, you get 4x squared plus 32x plus 64, so 32x. All right, make it to there. I'm losing people. Hey, the page was so nice until this problem.
Yeah, seriously.
That's okay. Hey, the good news is, look at how much you did. I mean, you did 1/9 of the page. 90% of the page. No problem. That's an A-. Okay. Now what?
Right. Quadratic equation / factoring /
Let's
divide by 4.
pull the 4 out first. That makes it easier.
I drew it like 4.
Now what? Now factor. And now we know that x equals -6 and x equals 2.
But one of those isn't right because we know we have an extraneous.
We do have an extraneous solution. I have told you that. Figure out which one's extraneous, please. Yes?
Can I write an equation up on the board that's a really important equation?
Not yet. That's our original equation. Yeah. You can. Go ahead. -6 works. Two is our imposter. All right. Hey, need everyone's attention here so we can wrap this part up. What do the two equations have, the two original equations that gave us extraneous solutions? What do they have in common? Talk with your neighbor. Number 5 and number 10. What do they have in common?
They both have a 7.
It has nothing to do with the 7. Everyone's attention back up here. Hey, right here, please. Here are the two equations. Let me even narrow it down even more. You get extraneous solutions when you have to do a specific thing to both sides of that equation. What did you have to do first? What did you do first in both of these? You squared both sides. Anytime you raise an equation to an even power, there is a chance you will get extraneous solutions. Okay? Anytime you raise an equation to an even power, because you've made an x squared by doing that, you could get extraneous solutions. Okay? So we started without an x squared. We ended with, at some point we added an x squared, meaning we've added solutions into that problem. Some of those, sometimes, just like we've done in other ones, like on number 8, it's okay. Okay? Sometimes both of those solutions work, like in number 7. It doesn't mean you will always get extraneous. You have the chance. If it's an odd power, you don't have to worry about that. Okay? Yes, Emily? Okay. Very good. Your assignment today is page 142 of the student journal. Now, please note on 13 through 14, they have inequality symbols. No big deal. Just think through it. Number 16 has lots of words. It's okay. You can read it, and I think you'll do okay. Okay?
Can I write the special equation on the board now?